Hello dear students, hope you have go through the first two videos of our electronic circuits on unit 1. We have discussed about that fixed bias, voltage divider bias and feedback bias concept. First, keeping that IC constant, we have to make that bias in stabilization techniques. We have derived that stability factors S dash and S double dash, which keeps the IC constant. Okay, and now we are going to discuss about the compensation techniques. Here we are not going to use resistors to compensate that changes in IC value. Here we are going to use diode, transistor and thermistor sensistor, which are temperature sensitive. So if there is any increase in the temperature, that will be compensated by using these devices. Let me start with diode compensation technique. Here we are compensating the changes in the temperature which causes changes in the VBE value. See that one. In the circuit we are using diode in the emitter side. If there's diode and the transistor are made up of same material. So if there is any increase in the transistor current due to increase in temperature, that increase in that voltage level will compensated by the same increase in the voltage of the diode. So but the diode is connected in the negative side. So if increase in the VBE causes same increase in the VD but in the negative direction, this is compensated and we keep that IC constant due to the change in temperature which causes change in the VBE. Okay, next we are going to discuss how the ICO, changes in ICO due to temperature increases compensated. Here we are connecting the diode in the voltage divider bias circuit. Okay, in the base emitter side we are connecting the diode and the diode is connected in reverse direction. So if there is any increase in the output current due to the increase in the temperature, that is compensated by increase in VBE reduced by the increase in the diode in the negative side. Okay, so this is how you are compensating the ICO and VBE by using diodes. Okay, next we are going for the temperature sensitive devices, thermistor compensation. Here we are using thermistor which is having negative temperature coefficient. That is, if there is any increase in the temperature, that causes decrease in the resistor value. See that one where we are using the thermistor. So if we are using the thermistor in the voltage divider circuit, if there is any increase in the temperature, that causes decreases in the resistor value, which again decrease the VBE value, that causes output current decrease. Okay, next we are going for that sensistor compensation. Sensistor has positive temperature coefficient. So when you are using that positive temperature coefficient sensitive sensistor in the above, that is between the VCC and base, if there is any increase in the temperature, that cause increase in the resistor value. Since sensistor has positive temperature coefficient, the increase in the resistor causes VCC value to be that is base current to be reduced due to the decrease in the VCC value. Okay, this again causes output current to decrease. Okay, this is how we are compensating the changes in the temperature which causes changes in the output current. Okay, we have discussed about stabilization techniques as well as compensation technique. In stabilization techniques, we are keeping the operating point stable by inserting resistors in the input side and output side. Okay, by giving negative feedback and by giving voltage divider biasing, we are keeping that IC value constant. But in that compensation technique, we are compensate the change in the temperature by using temperature sensitive devices. Okay, now we are going to discuss about that FET and Mosfet biasing. And as in BJT, there is no thermal runaway in the FET. Okay, since there is no thermal runaway in the FET, there is no need to go for the compensation technique. Just we have to go for the stabilization technique. Here we are, as we have discussed in BJT, here also we are having three biasing techniques, which one is fixed bias circuit, self bias circuit and voltage divider bias circuit. Here is the fixed bias circuit. In this one we are, see that diagram, here we are fixing the changes in the output current ID. changes in the ID is compensated fixed by using one voltage source VGG as well as one resistor RG in the input side. Okay, so there is any increase in the ID due to the increase in the input voltage, that is compensated by this increase in the by using this VGG. Okay, see that one, VDSQ is equal to VDD minus ID into RD. Here we are fixing that one, that changes in the voltage VDSQ by reducing the current ID. Okay, but the disadvantage of this one is we are using two power sources, that causes more cost effective. Okay, next we are going for self bias circuit. This is most commonly used circuit. Here we are not using two voltage sources. Okay, the changes in the circuit is compensated by this, changes in the output current is compensated by using two resistors. This RB is this RG and RS is used here, and by keeping this one, by using this one, we are compensating, we are reducing the changes in the output current. Next we are going for that, this stabilization, that self-biasing of a JFET stabilizes the Q point operating point against any changes in the parameters like transconductance, any increase in the voltage drop across R, and we are keeping that voltage become more negative, and thus increase in the drain current is reduced. Okay, next we are going to discuss about voltage divider bias circuit. Here you are using voltage divider bias, which divides the input voltage level, so that causes ID constant. Okay, and then we are going for biasing Mosfet, same as your JFET. The same biasing techniques can be used for Mosfet also. Here we are giving a simple sample for that one, N-channel enhancement type Mosfet, which is having fixed bias and voltage divider bias circuit. Okay, the same way we can derive this one biasing also. Okay, this is how you are doing that compensation and stabilization techniques for BJT. We have completed that stabilization techniques, and we have derived the stability factors for all the three biasing circuits, and we have go through the compensation techniques, and we have go through the FET biasing and Mosfet biasing. With that we have completed the first unit.